It sounds like it's going.
Okay. So welcome everyone to week 2 of the W3C and OGC's joint workshop on maps for the web. Bit of logistics in case we have some new visitors. We're talking live on Zoom chat. There will also be all the videos posted to YouTube later. Live chat as we go along, including questions for panelists. It's preferred if it goes into the Gitter chat. I've posted the link in the Zoom chat. Beyond this, the Zoom chat we try and encourage only for Zoom technical issues because it's not an archived forum, and we'd like to keep the conversation going for people who can't be here right now because it might be a horrible time where they are. Thank you for those of you who are here right now, even if it might be a horrible time. We're glad to have people to talk to. And of course, for longer form discussion lasting after the call, we have the discourse discussion as well. I would like to remind you that we are operating under the W3C's Code of Ethical and Professional Conduct. If you have any concerns about anything that is happening in the sessions in the chat, you can contact any of the program committee or the W3C Ombuds office. I would like to thank Natural Resources Canada, who have been sponsoring a lot of the work on this workshop. And including the captioning. If you're here live, there is somewhere in your bottom toolbar of your Zoom option to show the CC closed captioning of the discussion. I think that's all our logistics. I'd like to get started. Our first theme of the day, or a theme for the first hour, is how maps can improve accessibility for people navigating in the real world. We're going to start with 2 talks and then have a panel. Our first talk is by Sebastian Felix Zappe on physical accessibility data and maps. Sebastian is tech lead at Sozialhelden in Germany, a nonprofit focusing on disability rights. They're involved in many different projects on this theme, including Wheel Map, online map of accessible places, and Accessibility JSON, A11Y JSON, a data standard for describing accessibility, and the W3C community group on linked data for accessibility. So that's about all the information I have. Sebastian, I welcome you to take the mic and share your screen.
Yes, I hope you see everything and you can hear me. Thanks for this introduction. Yeah, I'm Sebastian Felix from Sozialhelden. Welcome to this. Let me start quickly. So what we focus on today is mostly these things. If you have a physical place, you often have the problem, can I get in? If you, for example, have a stroller for your child, or if you have a wheelchair, or if you're blind, or if you need spaces to be a bit quiet for you. And there are many other examples where you might find a physical place not accessible, and that's what we care for. We built this thing called wheelmap.org. That's an app you can download for your smartphone or use in the browser. And it just shows you accessible places all around for people with wheelchairs, in this case. They are just marked in red, green, or blue here on the screen to show if they are accessible. And if you zoom a bit in, you can also see that they are shown in different ways. So everything that's green is a circle, everything that's red is a square, which means it's accessible for people who are colorblind. So it looks a bit like this. If a place is fully accessible, it's as I said, green and a circle. If it's partially accessible, it's a polygon in orange. If it's not accessible, it's a red square on this map. And I would also like to recommend, if you do anything that has to do with accessibility, use something that is as simple as this. We are available in 32 languages right now. So it's already quite international. And wheelmap.org is based on OpenStreetMap. So this means all the information you put into Wheelmap is uploaded to OpenStreetMap, and the other way around, if you mark a place accessible on OpenStreetMap for wheelchair users, then it's going to show up on Wheelmap as well. We started around 10 years ago with this project. In the meantime, we've got around 1 million OpenStreetMap-based places on wheelmap.org that are marked as fully, partially, or not wheelchair accessible completely by users. The thing is, when you build an application like this, you build a kind of second world for people with disabilities. And the question is always, does this mean, like, is this issue solved now for people with a wheelchair? So if you've got wheelmap.org, does this mean that you can now like use the world? Does this mean equal participation? And we think it does not. We think that things like Wheelmap and other apps for people with disabilities are just a intermediate step towards disability mainstreaming. Disability mainstreaming means that all accessibility information should be available everywhere. So we think that this information does not belong into Wheelmap. It belongs into Google Maps, for example. It belongs into Apple Maps and Yelp and all the apps that are related to this. So basically, every app use case should be available for as many people as possible. We think that Maps for the Web, and now we finally get to why we are here, is a perfect case for this, because everybody who uses a computer, which is not everybody in the world, but most people, uses a browser for browsing the web. And if we can make applications accessible in browsers, in all browsers, then this is a big step towards disability mainstreaming, because this means that everybody can participate in everything that's available on the web. So our question was, could we make maps for the web specs to make accessibility information available everywhere? So can we kind of solve a part of this issue? Let me first make a short excursus. Where can you get physical accessibility data? So if you build a map application, for example, and you want to build in accessibility, you have to, of course, know where to get this information, if it's accessibility about physical places. So first, of course, you can go to OpenStreetMap. There could be an example where there is a hotel on OpenStreetMap and there is a way that connects this hotel to the next street, which is connected to the next subway station. And all this information can be augmented with accessibility information on OpenStreetMap. So you can, for example, say the hotel has an entrance. It's at a specific location on the map, and it might have multiple entrances. And one of them is wheelchair accessible and one is not, for example. The hotel could also have tags on OpenStreetMap that tell you that it's, for example, a quiet space, or that there are tactile pavements that allow you to access this entrance. So you can get data about accessibility from OpenStreetMap already. So this is already existing. You can, of course, also get it from wheelmap.org, as I just said. On wheelmap.org, you might also have information about a specific hotel's entrance, and if it has a ramp, for example, if this ramp is fixed, if this is a fixed installation, or if it's a mobile ramp that has to be put there by somebody. And you can also find information about rooms. So for example, if there is a bathroom or a specific kind of toilet and what kind of amenities this toilet has. Or you could, of course, go to a hotel booking platform that's kind of obvious and find photos there about how the place looks. And if you can look at photos, if you have this ability, then this might help you to, for example, prepare yourself to enter the place through this one entrance and to see beforehand how it looks. For information like this, Sozialhelden has built Accessibility Cloud, an open online platform for sharing this kind of data too, because OpenStreetMap is already quite nice for this whole thing, but we think it should be, it should contain more accessibility information. So on Accessibility Cloud, we have an API that you can use. It looks a bit like how I show it here on the screen. So you can have an application token that you can register on this web platform. And here in this case, use a curl request to query places on a map, and you get back GeoJSON in this case. Accessibility Cloud is connected to a lot of partners in the meantime. We are supported by a lot of organizations that share data on accessibility, in many cases for free and as open data. So you can use it in your apps as well. 3 apps that use this API that are shown here are Immobilien Scout 24, a big real estate platform in Germany, iWheelshare, which has a chatbot to query accessible places all around you in France, and wheelmap.org itself. So it's like if you as a partner or as an accessibility data source are connected to Accessibility Cloud and register there and put your data online, it's pretty easy to let it show up in applications like the shown ones here, and also of course in maps for the web applications soon, I hope. So here are the 79 organizations that Accessibility Cloud right now is connected to. They contribute around 1.3 million places to Accessibility Cloud and Wheelmap, and 3.8K real-time elevators as well to Wheelmap. So this is also containing live data, which is also really relevant because if you have, for example, a wheelchair, or if you're blind, you're often relying on elevators and escalators, and they are often out of operation. So if you know this in advance, this is really, really helpful. The problem with all this is that there are many accessibility datasets in the world, and they are not very standardized. They all use very different vocabularies. So we need to kind of harmonize them to make these available on Accessibility Cloud. And in many cases, this means somebody sends us a CSV table or something, and all these CSV tables look very, very different. So we created a standard called AliJSON. You can look it up on alijson.org. It's a standard that is meant to harmonize all these different vocabularies that allows you to query information, for example, about a toilet in a way that always looks the same, no matter which kind of data source you look at. So I will give you a code example now. It looks like this. So the code shown here is a GeoJSON feature on a map showing specific cinema. It's got a geometry and properties, so you can see that it's a cinema and how the cinema is called. And it includes a accessibility property as well. And this accessibility property is formatted in AliJSON. And what you see here in this code snippet, in this AliJSON code snippet, is that the place has 2 entrances. That one is the main entrance, and the other one is a side gate, and that the side gate has a fixed ramp, and that the main entrance is level, so you can access it without a step, and that its name is 30th Street. It also shows that the cinema is accessible with a wheelchair, and that there is an animal policy that means that the cinema allows you to enter with a guide dog, which is not a law or something in every country. So it might make sense to mark these places, so you can know which place, for example, you can enter with a guide dog and which one you can't. So there is this animal policy thing in AliJSON as well. Here are some interface specifications that AliJSON specifies. So there is accessibility, there is this previously described animal policy, you can describe elevators, escalators, folding handles for toilets, ground quality, media, mirrors, parking, pathways, payment, personal profiles. So it means you can have data sets that tell you that specific groups can access a service or a place infos. So for example, like the shown cinema, it describes ramps, restrooms, rooms, showers, for example, training for staff. So if staff has a certificate and is trained in specific things, then you can also mark this. It describes stairs, tables, toilets, wash basins, wheelchair parking, and wheelchair places in cinemas right now. So these are the main interfaces that you can find in AliJSON and already use. And what this all is meant for is we have a lot of these platforms on the web. So all of these platforms could publish AliJSON data. The thing is that AliJSON itself isn't what we want. It's also just an intermediate step towards something bigger. And what we want is we want all platforms that exist on the web to semantically describe their content on the web with stuff like schema.org, for example. So we looked at schema.org and we also tried to extend schema.org with missing vocabulary for accessibility. On the screen, you see some of these platforms and how they describe accessibility. And we don't want this information to be just there on the web pages, but of course, a user who wants to look up all these things, for example, somebody who wants to book a room on a hotel platform wants not to look at like 3 websites, for example, or like 10 websites to find all this information, but they want to have everything in one place, obviously. So if they go to a platform, let's say booking.com, they want to have all the information right there when they look at a room, at a specific room that is offered on the web page. They want to know about the accessibility as well, and that's of course true for everybody who uses a booking platform. So all the information from these platforms has to somehow end up there. And this is what linked data is for. This is what schema.org is for. So schema.org allows you already to describe, for example, how places are connected, what kind of place you have in front of you. So if it's for example a cinema or a hotel, and it allows you to link data across several platforms and easily connect it with each other. So how could you describe physical accessibility in these standards? The thing is that this is not standardized yet. This is something that has yet to come. So it's not there yet. And we thought about some ways to maybe get it standardized in maps for the web as well. So here are next 2 ideas, how we could describe all these things in maps for the web. First example, there's a map ML proposal, and we think that it might be a very, very good idea to, as early as possible, extend it with semantical data. So currently it's something that is very, very visual. So it contains geometries and it contains information about how to render these geometries correctly visually. But if you would describe the features that are shown on the map or in a visualization, in a geo-visualization, if you would describe them with semantic metadata, the browsers or the user agents, for that matter, could find out what the shown data actually means, which is currently not possible yet. So this needs this kind of proposal. What is shown here is a feature in MapML, so probably rendered as a marker on a map. Again, a hotel. And what we thought was we could just extend this with things like microformats or with RDFA, for example. So this is looking like the RDFA standard in websites. And it describes that this shown feature on the map is a hotel. and that it has a specific amenity feature. And for this semantic description, it uses schema.org. So it uses features that are already available in schema.org. So this could, with this very simple proposal, already be done. It would mean that a browser would understand that the shown point on the map is a hotel, and it would be able to, for example, read to a user that this hotel has a wheelchair accessible sauna, which is specified in this code. Another example that we thought of was we could easily just add AliJSON as a subproperty in CityJSON. So CityJSON is a format that describes whole cities, their buildings, their building parts, and for example, entrances on in buildings, and the buildings inside as well. So it can be used for indoor mapping. And the building parts could just be augmented with this accessibility. As described before, it could just be AliJSON built into CityJSON. This proposal does not exist yet. This is just an idea, and we'd be happy to talk about this in the later discussions. If this is a good idea, maybe you have better ideas and better feedback how to get this done. And if we put this into CityJSON, this might be a great way to easily integrate accessibility for physical data into browsers. If we do this, this opens up a lot of new possibilities, because of course user agents can be extended with browser extensions. It means that everybody who has a specific need could theoretically download a browser extension that would change the display of an existing map to their needs. And this is a really, really, really big thing, because this does not exist yet. And this would be very, very helpful. So just imagine, it could even make real accessibility better in the world. So there could be built-in things like, if a place is more accessible than a different one, the more accessible place could be ranked differently in the labeling. So for example, let's say you are blind and you need a restaurant, for example, to be accessible for you, and maybe have a braille menu, just as an example. And this braille menu would be specified in AliJSON. Then the places that do have this could be shown as labels in higher zoom levels, in lower zoom levels, and the other ones could just be not read out by the screen reader. And all the most relevant places for you would just be like read first with a higher rank. So like, for example, Google ranks web pages by their accessibility. A map could rank places by their accessibility. And this would be an incentive in the real world, just for marketing reasons and for visibility reasons, for example, restaurant owners, for hotel owners, to build in real accessibility just because it makes them more visible on the web. And this would be a really, really big thing, because it would change the real world just because we would build an algorithm for it. And this would be something that would be really nice. Some other examples include colorizing places as shown on Wheelmap using a traffic light system. So if a browser knows that a specific place has a ramp, for example, it could mark this place green by default, without the author of the map having to do anything. It would just be built into a browser or a plugin. It could add indoor map context links to places. So for example, you could right click on a place, and by right clicking on your desktop on this place, a context menu could show up and offer you an indoor map in a different application, because you would have the semantic info about the place. Or you could augment maps with accessibility features. So for example, wheelchair users could always see elevators on this map. Like no matter which map it is and by whom it is made, elevators could just be displayed because there is a browser plugin for it. And nobody would have to care as an author. Or it could be displaying accessible toilets. You could be displaying inaccessible or accessible sidewalks. For example, if they've got a bollard on the sidewalk, or a difficult sidewalk surface, which is relevant for many people, it could just be displayed on this map. And it could be displaying ramps and stairs. Or many people need specific environment noise levels and have difficulties, for example, with hearing and listening to a conversation if the environment noise level is high. This is also stuff that could be displayed on a map. And last, it could allow voice assistant to understand what map features actually mean. Something that's really important here is that
Sebastian,
yes.
How close are you to wrapping up? We're going over time.
Almost, like 2 minutes, I think. Is that okay for you?
Quickly.
Okay, so what's really important here is, of course, a user doesn't want to disclose their health in an application. So all these Ali features, if they are built into browsers, they need an extra layer of protection. So, for example, a disability is not disclosed to every website I visit. So like a location, a browser should allow you to allow or deny to share this information with the website. And browsers and plugins should not reveal it if you don't want to share it, of course. The other thing is that you always get this issue with user intent versus a map author's intent. So you could have something like ARIA labels. So like HTML has ARIA labels, you could also add this to maps to give as an author hints to a screen reader or to user agent how to use a map for accessibility. It could say something like the visual style of this feature should be rendered like this, if this is possible, or it can say a map is a geodata visualization, or it's made for discovering places which are like totally different use cases. So the browser could use this information to make the map more accessible as well. And how you can help for making all this happen is participate in schema.org's GitHub issue 254, which is the accessibility GitHub issue in schema.org, and help us get this into schema.org. Of course, participate in the W3C linked data for accessibility community group. This would be really helpful. So if you can join this and join this discussion, do so, please. And give AliJSON a star on GitHub to make it more visible, because many people don't know that this exists yet. If they would know, probably they would already be using it. And add data sets, if you know them, on Accessibility Cloud and other platforms to make them available to the world. So that's my ask. Thank you for listening and watching.
Thank you,
my
Sebastian.
Contact information.
Well, I already see there's lots of questions going on in the chat. People are excited about GeoJSON and linked data around here. So I hope you can connect up with people. I'm going to continue on to our next talk. Claudia Loitsch and Julian Striegl. Somebody else is sharing the video? Okay.
Yes, I'm going to share
Thanks,
it for
Peter.
Claudia. Yeah, no problem.
Okay, so Claudia Loitsch and Julian Striegl recorded their talk in advance. They are researchers at Dresden University of Technology, focusing on mobility-related requirements of people with visual impairments, in particular with a focus on navigation and orientation in indoor spaces. Okay.
Hello and welcome everybody to the presentation Accessible Indoor Maps, Information Need and Automated Solutions to Address Gaps in Maps for People with Disabilities. My name is Julian Striegl and I'm presenting this topic together with Dr. Claudia Loitsch. We both work at the Dresden University of Technology. In our project Accessible Maps, we have an international and interdisciplinary team of the Dresden University of Technology and the Karlsruhe Institute of Technology. And we are working together on innovative and new solutions to improve mobility within buildings. Our project aims to develop software that automatically generates indoor maps enriched with accessibility features. And you can find more on our project on our website, accessiblemaps.de. Our main motivation is the social relevance of the topic, in particular because independent traveling and mobility is challenging for people with visual and mobility impairments. People with disabilities face several barriers when navigating to or orientating in unfamiliar buildings. Overcoming permanent or temporary barriers is very challenging for people with disabilities, And for instance, you can see on the slide that ground level objects are sometimes not detectable for blind people using a cane. So why do we focus on indoor maps? Well, compared to outdoor and public transport, the indoor area has so far received the least attention, least in terms of data, maps, and user research. And we believe that in addition to navigation applications, indoor maps will help with the orientation in unknown buildings for people with disabilities. If you want to create accessible indoor maps for people with disabilities, you first need to understand the needs and abilities of those people. People with disabilities need granular information about the layout orientation features as well as temporal relations, for example obstacles such as construction sites, to find their way independently. Mobility impaired people primarily require structural information as they experience barriers such as narrow doors or passages, lack or non-functioning elevators and escalators, lack of handrails, uneven walking surfaces, and heavy doors. Furthermore, mobility impaired people rely on information such as slope of path, floor covering, manual or automatic opening of doors, or accessibility of restrooms. Visually impaired people also require structural information such as handrails and wayfinding information, and they can experience barriers in complex and confusing buildings or buildings with bad lighting conditions. Moreover, information about the availability and location of braille signs and tactile paving is helpful. In addition, it is important to understand that people with disabilities have different requirements for planning of a trip and its implementation. The diverse information need is represented in Table 1. You can see, for example, that information about the type of doors or the location of a floor plan are more important for people with visual impairments if they are within a building. A problem, however, is that no common approach to collect and make information about physical accessibility of buildings available for different user groups and for all parts of the travel chain exists currently. Therefore, collecting those information is time-consuming or even not possible. It requires users to know where they can request their required information. Accessible maps for the indoors can be a solution, but they must represent sufficient data about physical accessibility and they must be accessible for diverse users and contexts. Before being able to present accessible maps to people with disabilities, it is of course necessary to have a good databases of indoor maps. Currently, there are no widely accepted open standards for the expression of accessibility information in indoor maps, and there is a lack of methods to assess if indoor maps comply with the requirements of people with disabilities in terms of orientation and indoor navigation. In the scope of the Accessible Maps project, we therefore analyzed the quantity and quality of indoor maps exemplary for OpenStreetMap, as it is one of the most successful volunteer geographic information projects. To analyze the quantity and quality of existing indoor maps in OSM, we used the Overpass API, and the used requests for the API were formed based on tags specific for the mapping of indoor areas with the simple indoor tagging schema of OSM, which is the currently chosen standard schema for indoor mapping in the OSM community. The bare minimum of needed tags for a working indoor map in OSM are the min level and max level tag on the building polygon or the building relation, and the level tag on points of interest inside the building. Furthermore, the four basic indoor elements, room, area, wall, and corridor, can be used to model the floor plan of a building. As a first analysis of the state of indoor maps, we looked at 4 major European cities, Berlin, Rome, Vienna, and Paris. And 2 main statements can be derived from the collected data. Firstly, for all European cities, there's a strong imbalance between the number of objects marked as buildings and the number of objects marked to be in an indoor environment with the indoor yes key value pair. This indicates that the number of mapped indoor environments is sparse regardless of the used indoor tagging schema. Secondly, even though SIT, simple indoor tagging, is the tagging schema currently chosen for indoor mapping by the OSM community, only a small percentage of objects have SIT associated tags. And on the left-hand side, here you can see an example of the discrepancy between the number of buildings that have an SIT-related tag and the number of buildings that are completely mapped using SIT. The quality of mapped indoor geospatial information in regards to accessibility is of utter importance when analyzing how existing indoor maps and OSM suit the requirements of people with disabilities. Therefore, mapped buildings were further analyzed in regards to their consistency in used indoor tags, their completeness of provided indoor geospatial information, and mapped accessibility-specific features such as elevators, ramps, provided braille signs, and tactile pavings. On average, only 6.75 buildings per city fulfilled the minimal SIT requirements, and on average, only 1 building per city met the requirements of SIT completeness. In the complete dataset, only 4 buildings included mapped accessibility features for mobility impaired people, such as ramps and elevators, and none of the analyzed cities had buildings with mapped accessibility features for visually impaired people, such as braille or tactile paving. An example of the fluctuation in indoor map quality in OSM can be seen on the left-hand side. Both depicted buildings fulfill the minimal SIT requirements, however, only the upper map has sufficient information to be suitable for indoor navigation purposes for people with disabilities. Let us now briefly talk about accessible representations of indoor maps. There are many and diverse approaches to make visual maps accessible, but mainly for people with visual impairments. On the slide you can see 3 different techniques. Tactile maps are most frequently used and effective for learning spatial structures and for orientation and mobility training. On the slide you can see an indoor map that is produced on swell paper. Another technique are virtual acoustic maps, which convert map items into different sounds and directly inform the user about the environment. Microsoft has, for instance, developed the app Soundscape that enables people with visual impairments to hear landmarks around them in 3D. Another technique are audio tactile maps, which is again another technique that focuses on multimodal interaction techniques to augment maps with auditive information. There are again very different approaches. On the slide you can see a refreshable and touch-sensitive braille display with which a blind person can explore a tactile map. Additional auditive information can be received via a tap gesture. There are many more techniques that address the need of people with visual impairments. The problem is that currently there are no standards on how maps and geographical data should be made accessible for different contexts and diverse user needs. So we know less about how people with impairments in the upper body can interact with maps, or how maps can be simplified for people with mild or severe cognitive impairments. Several key challenges can be derived from the analysis of the state-of-the-art of accessible indoor maps for people with impairments and from the analysis of the requirements of the different targeted user groups. Firstly, there's currently a low coverage of indoor maps, and indoor schemas are inconsistently and incorrectly applied. Specifically, information on accessibility for indoor areas is not available for most public buildings, and there's a lack of standardization for the accessibility domain. Secondly, the data collection process for indoor accessibility information is quite tedious. The required level of detail of indoor information is too high to achieve with traditional mapping methods. Commercial digital map platforms focus mostly on the mapping of points of interest instead of mapping of detailed geospatial information. Thirdly, there's a lack of knowledge concerning the information needs of people with disabilities in the mapping community. While accessibility projects do exist in the volunteer geographic information community for the outdoors, similar projects are needed for indoor environments. And lastly, people with disabilities are a diverse user group with varying sensory, physical, and cognitive abilities that can lead to different accessibility challenges with digital maps. To tackle those challenges, we propose the following possible solutions for the collection and representation of accessibility information for indoor areas. To tackle the challenge of the insufficient prevalence of accessible indoor geospatial information, semi-automatic processes for the creation of said information are needed. Therefore, in a first step, a vocabulary for the mapping of indoor accessibility features needs to be defined. Furthermore, existing maps in the varying schemas for indoor mapping should be transformed to one basis of data. Already existing indoor maps need to be analyzed in regards to their quality of accessibility information, and therefore corresponding tools are needed. Finally, semi-automatic and crowdsourcing approaches should be used for the collection of accessibility information and the mapping of accessibility features in indoor areas. And based on the collected information, accessible and individualized representations of indoor maps should be generated. And you can see different examples of possible outputs on the right-hand side. Finally, we would like to say that the development of indoor maps is still in the early stages. It is expected that the market will grow significantly in the next years due to an increased demand from location-based service providers, who will take a more economically motivated approach, such as considering merely points of interest instead of mapping accessibility-related aspects. Therefore, we believe that it is currently a very good time to consider the aforementioned challenges properly and to take accessibility into account at an early stage in the development of standards for web-based maps, and not as an afterthought as it is usually applied. Our contributions to this area are dedicated user research for mobility in unknown buildings in the Accessible Maps project and beyond, software to significantly improve the coverage of indoor maps, and solutions for barrier-free map representations for different contexts of use. So we would love to get in touch with you for further collaborations and contributions to this topic. And with that, I would like to thank you all for your attention, and I wish you a pleasant day.
That was Julian Striegl on the recording. His colleague Claudia Loitsch is with us here today, and as always, keep posting your questions in the GitHub or Discourse, and we'll try and continue the discussion beyond here. I'd now like to ask our members of the panel to join us. I think though we are still missing someone. I haven't had any response from Lisa Seeman, so I hope she is well and just having internet difficulties. We will do our best without her. So our next topic of the day is continuing along this theme of accessibility, or maps helping with accessibility in the real world. The panelists are members of the Cognitive and Learning Disabilities Accessibilities Task Force, otherwise known as COGA. So I'm going to let each panelist quickly introduce themselves. Let's go across on my screen, John Kirkwood.
Yes, hello, can you hear me?
We can, you're a little quiet.
Okay, is that any better?
That is.
Okay, distance from mic. Okay, hi, my name is John Kirkwood. I'm on the Cognitive Accessibility Task Force of the W3C. I'm very interested in this topic as well because I was the advisory committee representative for the New York City Department of Education for the W3C. And I was involved with making all of their sites for their various schools, 1,700 schools, accessible to people with disabilities, in particular their websites, but I also sat on their building accessibility board. And we needed to make every one of their schools accessible to people with disabilities, which includes, of course, wayfinding through every school and incorporates all the different types of disabilities that people have. So if one has a disability due to triggering from lighting, they would need to be able to have a map for them in order to make it through the school without getting triggered by these lights. So the former speaker talking about standardization of indoor mapping and bringing that to the larger scale would optimize the processes needed for, especially a large school system like the city of New York, to make all its sites accessible to people with disabilities, independent of their accessibility needs. And I said on the Cognitive Accessibility Task Force, the W3C, with other panelists here, talking and trying to figure out how to standardize around web accessibility for people that might have memory issues, queuing issues, sequencing issues, age-related issues that would affect their ability to navigate due to occipital lobe or parietal lobe issues with their brain functioning. So this is all very interesting to me, and lucky to join the other panel members on the Cognitive Accessibility Task Force here to discuss these things.
Thank you, John. Okay, continuing on, John Rochford, can you give us a brief intro?
Yes, absolutely. So I've been interested in wayfinding for quite some time, and the background material that Amelia posted to the conference agenda page, it has two documents. One is an issue paper about indoor wayfinding for people with cognitive disabilities, and I'm the primary author of that. And it also has my collection of wayfinding technologies that I've been keeping and updating for years, both indoor and outdoor. So I'm going to be adding to that collection all these wonderful resources that I've learned about in the past hour. And I totally agree with John that most of what I loved about what I heard was that, the focus on everybody, including people with cognitive disabilities. Many people with cognitive disabilities also have physical disabilities, so it's important to us too. But we have some unique needs. So an example of that is that people with dyslexia, for instance, have difficulty with left and right. They confuse them often. And so directions that say take a left down the stairs, take a right, that's going to confuse them. And another one is along their route, if they get interrupted, they have difficulty reestablishing the route. So if their supervisor says, hey, I want to talk to you about X, and then they have to go back to their work route, it's difficult. So that's really all I have to say, and that's as brief as I can be.
Okay, David, do you want to give us a quick introduction?
Yeah, sure. So just like everyone else, I'm an invited expert to the Cognitive Accessibility Task Force. I'm also a survivor of a traumatic brain injury. When I was 13, I had a hemorrhagic stroke the size of a softball in my right parietal lobe, left me blind in left half of each eye, cognitively impaired, and completely paralyzed in the left half of my body. I founded a company by the name of Helix Opportunity, funded by our nation's vocational rehabilitation system. And we focus on user experience and inclusive design consulting with an expertise in the areas of neuropsychological and cognitive design. So of course, this is really, really interesting to me, and an important aspect of what we do is user research on trying to figure out different ways to implement cognitive accessibility and design strategies so that people don't have these kinds of issues that John and John have both, discussed. And I'll leave it at that. That's brief enough.
Okay, so you've all kind of touched on this in different ways, but not everyone here is an accessibility expert. I think most people understand when we talk about wheelchair accessibility and ramps and why that is relevant to maps. Can we give a quick overview of what you mean by cognitive accessibility and how it is related to maps and web maps in particular?
Absolutely. I can start off just talking about three things I posted in the chat earlier: attention, memory, perception. These are super important because when you're going about your daily life and going through an environment, you get used to the environment that you're in. And once you get used to the environment that you're in, you stop perceiving things going on around you. you're still aware of them. Your body's still sensing these things, but you stop actually perceiving them and noticing that they're there. When we're talking about, there's two different kinds of memory, recall and recognition. When we talk about maps, we're talking about recognition, recognizing where you've been, where you're going, how to get there, and how to get back. If you're on your path and you've basically tuned out the world around you because you're used to the environment that you're in, everything seems kind of similar, and nothing catches your attention to let you know that it's a key marker that you need to pay attention to so you can find your way back, you're going to get lost. And the same thing goes for when you're going somewhere. If you don't know where to turn because something doesn't grab your attention, and in order to grab your attention, these cues is what they're called. They can be audio cues or visual cues. They have to be what's called salient, S-A-L-I-E-N-T. Salience is very organic, and it's very unique to each person, which is why user research is so important. Salience can be the size of something. It can be the shape of something. It can be the color. It can be the way that it moves. But if it doesn't have some type of salient prominent properties, it won't catch your attention. You will tune it out and you will miss it. Also, if you're stressed in this environment while you're going through it, you're going to miss these cues also, because what happens is stress blocks your brain from producing the cells necessary to create new memories. So as you're reading a map, going to an environment, your short-term memory is kicking off, connecting one dot to another, to another, to another. But if you're stressed out and your brain's not creating those memories for the short-term, or the cells for those short-term memories, you're never gonna make it. You're never gonna have that connection from point A to point B to point C. So that's why the map experience must be seamless. It must not be stressful, and it must be cogent and coherent for people.
Okay. Do either of the Johns want to jump in and talk about how that experience in how the brain works in real life relates to the experience of the map itself, and what can make a map or widget or visual map or whatever better for those types of comprehension?
I'll attempt a little of that. I think David made some very good points there, and sort of sketching out the needs there. And one thing that I too had a brain injury, and it affected my occipital lobe and parietal lobe. The parietal lobe is the area of your brain that actually does the mapping. And it's the part of the brain that lays down the maps for you. And I found that with my visual deficits and this particular issue with my parietal lobe, I was not able to essentially, as David said, remember sort of left or right, and that I couldn't do that from memory, but I used cues just like I would use walking through a hospital when I was recovering, and my cue would be, in particular, a painting on a wall, and I knew, hey, I might not know which direction I need to go. I might not be able to lay down a map in my head, but I knew that once I got to that, I needed to walk towards that painting, and once I got to that painting, I would look for the next cue. And I could go from that cue of memory. It's like, oh, now once I get to that painting, I looked and I saw the elevators. It's like, that's where now I've made it. However, I wasn't able to put that map in my mind's eye, but I was able to follow that story or have the breadcrumbs. And some people work by stories with their mapping, and some people might do it through internal mapping out in their mind's eye where they are in placement on the map. So the storytelling, the salience of that, and the ability to remember things and cue oneself by having that sort of impact of the story is a way that can assist people with mapping sometimes, or navigating.
So this is John Rochford. John Kirkwood, there's something about you that the left-right vision. Could you explain that, please? I think it's really...
Yeah. To be very specific, and this is similar to David as well, I think it's homonymous hemianopsia, which is half vision in both eyes. So I can see to the right. If I look at someone's face, as I'm looking at your faces on video right now, and if I look at John Rochford's face, and I look at his left eye, I cannot see his right eye. So thinking about that and how to navigate through a room, we walk through one room, and then you see a door and you walk through the other, and now you have to return to the table you were sitting at. And you've seen on that path, you've seen planter and a window, but on the return path, you're seeing a classroom with tables and a water fountain and an exit sign, which is nothing that you've seen going the other direction. So the idea of queuing and mapping and trying to relearn how to spatially navigate and to put that into memory so that one can functionally exist, that, as John was asking there, was specific to the visual center and the mapping area of the brain.
Yeah, can I just add something to that? So, you know,
Sure.
this is something that is true for all people, but for people with cognitive disabilities, we can have lapses in time where we blink and we don't realize how much time has passed. So, you know, when you're coming back to an environment and you don't recognize where you are and you thought you were where you needed to be, it can really bring on a lot of anxiety, a lot of stress, and really freak you out. And this again goes to how the stress can't create new memories and stuff like that. And that just completely throws everything off. And I remember times when I was 13 years, I was 14 years old. I was 13 when my brain hemorrhaged, but we had just moved to a new neighborhood and the houses were just being built up and all of this kind of stuff. And I was leaving the house, walking around the neighborhood. I'm a new kid, trying to find new friends to make, stuff like that. I would get lost for hours because I couldn't recognize the streets, the houses or whatever to find my way back. And I would freak out. I would almost like be in tears, not knowing what to do. And I mean, I can't tell people where I live because I'm new to the neighborhood. I don't know where, I couldn't remember my street name, you know? So, and that's for people with cognitive disabilities, but even for people without cognitive disabilities, the same situation happens. If you're on your way to a job interview or you're on your way to a date or somewhere important and you can't figure out where you are because you can't recognize the cues and stuff like that, it can freak you out.
Okay, that actually leads into my next question. So I think you've effectively convinced people that for someone who's had a traumatic brain injury, navigation can be incredibly difficult. But for people who are building a web map, there's probably some question about how big an audience that is, and is it really effective for them to think about it in every map they make, or is that something that people with accessibility needs will need special software? And
Yeah,
what is the broader interest here, or how can that connection be made?
So
Could I start with that one really quickly?
Go ahead, Roger.
John. Yeah, one thing, the way to really think about globalizing that is everyone at some point in their life, their parietal lobe will start decreasing in its functionality. And when you're aging, that's one of the things that does go is how to spatially navigate. And we will all have this at one point. And we will need help. And technology, as we're aging, will help us more and more. And as technology meets us as we all age, these things will be things that we will be completely dependent on. As we're dependent on our Google Maps when we're driving, we're going to be dependent on the indoor maps to make it through hospitals or rehab facilities or aging facilities or independent living for anyone. So that's one point I would like to put there.
And I have a number for you too. 300 million people will have dementia by 2050. 300 million around the world. That's a lot of people with cognitive disabilities. So if you're looking just for a number about what that's just one subset of disability. Then you've got people with developmental disabilities, people with brain injuries, from the military, from just regular life, all those different kinds of things. And like John said, plus it's just everybody in general as we degrade as we age. So it's important. And think about this, when you're driving around a city looking for a place, you know, a building or an event or a venue, it's really dangerous to have to be looking at a map and focus all of your cognitive resources on trying to identify where you're going as opposed to watching the road, right? So there's a huge market opportunity and implications for this.
Okay, so assuming you've convinced everyone that making maps better for cognitive accessibility is a necessity, what does that actually look like at the software level, at the geospatial data level?
Well, I'll start with that one. Delivering the right information at the right time. So
Okay.
if you might be someone that remembers 7 steps and directions, and you can say, okay, I just need to look at this once and I'm fine. But you might prefer to have your directions repeated to you when you are 200 meters from your next turn, or maybe you want it half a mile from your next turn. The customization of how information is delivered to you, dependent on what your functional memory needs are, would make it more accessible and more usable for everyone. And these can be learning, there can be a feedback loop in your own mapping programs, from your Google Maps to where you're driving when you ask for the directions more often, or from your maps in indoor wayfinding within a hospital, so that your information is delivered to you in the way that you need it in accordance with your memory functioning. That makes it a better user experience for everyone.
Okay. Any other comments on how map software can be better?
I'll just say one thing is that a lot of user research needs to be done, including people with cognitive disabilities and without. People with cognitive disabilities are one of the least, we're one of the neglected demographics when it comes to not just accessibility, but also in user research, because we're perceived as not really being active in the economy, you know? So a lot of user research needs to be done to actually flesh out what can help and benefit people with cognitive disabilities in terms of, you know, mapping and stuff like that. And another number for you is $19 trillion in household earnings is how much people in the baby boomer generation are worth. You know, if they're going to be out there spending money and stuff like this, we need to know how to help them best navigate their environment to get to the places to spend their money. And that's just in, you know, G20 economies. So, you know, user research is really important. We don't have enough data.
So
Okay.
my quick answer to that is that, just as John and David are saying, all the efforts that we've heard about today, including ours, everybody must involve people with disabilities in the development of these technologies, because if you do not, they will fail, and they will fail for everyone. And it's not just people with disabilities, it's all kinds of populations of people. People who have low literacy, people who can't read directions, for example. And there are enormous populations of people like non-native language speakers. So if you've got your directions in English, or you are relying upon colors to represent, like, you know, whether a place is accessible or not, and it's green and red, you know, green is good, it's good accessibility, red is bad. That means different things in different cultures. So my pitch to everybody is that all of this technology we're talking about and have been talking about has to be a group effort if it's going to be successful.
Providing salient cues is super important, but again, salience means different things to different people, which is why the user research is so important. So, I mean, I can't stress that enough. We need to do a lot of research on this.
Okay, so user testing, customization, and focus on how people actually recognize things in the real world. Very quickly, we're going to wrap this up, but I have a question from the audience. What is the room for web standards in achieving these goals? Can we standardize it, or is it just a matter of best software development practice?
We're working on it. That's why we have the task force. We just published a guide for making content usable for people with cognitive and learning disabilities. It's published as a W3C note, I want to say, but you can find it online. That should be pretty helpful to a lot of people. It's a good starting point. It's designed best practices and information about what people with cognitive disabilities experience. So yeah, we're working on standardizing it.
Okay.
It's right on the web accessibility information page of W3C.
We will find that link and add it to the chat.
w3.org/WA.
Any final comments as we wrap up the panel?
It's been my honor and privilege to participate in this. I really appreciate the opportunity. Thank you.
Well, thank you for joining us. It is good to have these perspectives on how software and web maps can actually impact people's lives.
Really, I'm thanking you for your expert moderation. Thank you very much.
I would also like to
you
add
all.
in that we on the Cognitive Accessibility Task Force, this is something that we very much welcome input from professionals or people interested in the field, because it is a very large area, and as you take the layers of the onion off, I think we all realize that this scale is very large, and we need help and expertise around that. The more that we can get, the more involvement we can get from people, we welcome it with open arms.
We wish we had more concrete, technical specs to give you on what you could implement, but that's, where it's lacking. We need more collaboration.
Mm-hmm. Yeah. Needs more research is often the conclusion.
Mm-hmm.
Well, thank you. We're going to wrap up the panel, and I'm going to immediately change gears to our second theme of the night because we are running a little behind schedule. Now, our remaining talks are on the general theme of can we improve map data web servers and map data formats to make them better for web use. And I'm going to start with a pre-recorded presentation by Nicolas Rafael Palomino. So Nicolas is a researcher studying on wireless telecommunications and unified telecommunications with a focus on geolocation and geospatial data. And his presentation is on Advanced Analytics Software Project for Geospatial Data. Can somebody please let me know that you're seeing the video player?
Yes, we are.
Okay. And the zoom overlay is right on top of the play button. There we go.
Hi, as mentioned in this page, my name is Nicolas Rafael Palomino. In this presentation, we'll be talking about advanced analytics for geospatial data. We'll be discussing why and how harnessing big data with complex mechanisms is essential to be implemented by the tech industry to keep their place as we move forward to the edge. We will start the discussion with the interactive maps widgets and its infrastructure, and I will explain why advanced analytics are important to be harnessed and implemented in the digital cloud-connected infrastructure. So, here we can see some basic maps widget we could interact with. The picture of the map you're looking at is showing downtown Montreal as a basic potential map format. What we're trying to do here is to integrate new technologies including advanced computing, big data analytics, and artificial intelligence to set up the advanced analytics that will autonomously or semi-autonomously examine data or content using sophisticated techniques and tools, typically beyond those of traditional business intelligence, to discover deeper insights, make predictions, or generate in real-time data to bring life to the Internet of Things. In the next page we have bringing life to the Internet of Things, which will be one if not the most important constituent of the whole IT system. In the most small rectangle you can see the experience of the user that is shaped by the advanced analytics, and that experience will be the customer or individual interacting with the whole platform. This part is autonomous and best suited to serve the individual, customer, or person using the services. This will be done through the system of advanced analytics. This system will be leveraged by artificial intelligence, machine learning, and advanced analytics to give a more in-context, predictive and pervasive geospatial data available to the persons using the navigating tool, and all that will be running on the cloud-connected IoT devices. Next up we have the values that are unlocked by using this new infrastructure. The first point here is the new business models, implementing hybrid IT cloud, or any cloud services to business interconnection systems will redesign the centralized IT infrastructure, because distributing network hubs in locations at the edge offers direct access to customers, partners, and other ecosystem participants, leading to new business models and business intelligence, and that will bring new business models. Second, we have the seamless customer experience that will be fueled by artificial intelligence, machine learning, and advanced analytics that will be running on cloud services. This service will enhance many aspects of life, such as the safety and security of whatever transaction is going on, as well as the quality of services that are provided, either physical or digital. This optimized responsive value chains will connect in real time and in context physical and digital materials with different types of computing services and processes, bringing predictive and pervasive ecosystems. Here in the next page we have the basic uses provided by the interactive maps. The first point here is an interesting concept I've experienced myself. Basically, I went to a restaurant during the COVID-19 pandemic, and I noticed the restaurant was not providing menus, but instead they told us to scan a little QR code with our phone cameras, and that code redirected us to the restaurant menu with a hyperlink. I think that's a perfect example of a service that could be provided and optimized by using different layers of ecosystems involving intelligent machine-to-machine and human-to-machine communications, and different layers of artificial intelligence, machine learning processes, and analytics through the cloud interconnectivity infrastructure. Such technological mechanisms will provide the user a much more adjustable and client-centered services. The second point is retail stores or commercial uses, which does not really differs from that restoration system I experienced, but yet are two different systems in a way because of the different variables. The way we want users to generate data is by making them access and interact with any type of data in IT system that is useful to them and that can be provided by the factory, retail store, or any data that is accessible by location or non-location. Smart factories are defined as flexible and fully connected factories that are able to make use of constant streams of data from operations and production systems. The amount of possible interactions is endless and creates unprecedented industrial scenarios where items can talk to each other with tools, machines, remote computers, or workers. Human-centered design is an approach to systems design and development that aims to make interactive systems more usable and useful by focusing on their use by operators and their requirements within a collaborative industrial environment. This approach enhances effectiveness and efficiency, improves human well-being, user satisfaction, accessibility, and sustainability, and counteracts possible adverse effects of use on human health, safety, and performance. These systems, together with the design principle of the Industry 4.0, will connect manufacturers and retail supply chains to a real-time and in-context live interaction with the merchandise, stock, and service availability provided by any retail store at the edge. The third point is the social uses of such infrastructures. Here, we'll explain the facade by which social features will be leveraged to exploit and generate data from users, providers, and IT systems. It is more likely that these type of mechanisms and digital functioning will be exploited through social mobile applications based on geolocation. We believe that the best way to leverage big data, analytics, and pushing digitalization with these mechanisms is by setting up an open map mobile application that the user will use to navigate. Geospatial data should be allowed to be interacted with from a local or non-local point, privately or publicly doesn't really matter as long as data symbiosis is achieved and stored for advanced analytics and Industry 4.0 designs and architectures. Public, private, and individualized servers have to be available to achieve maximum capabilities of harnessing big data. Next point is the 5G, which is fifth generation technology standard for cellular networks. The implementation of 5G will be a game changer to the use of these systems, as a few companies already started providing 5G wireless transmission, but we'll discuss about this further in the presentation. Next up we have the commercial systems components that will bring the Industry 4.0 in place. So, first, we have the vertical and horizontal integration systems that are key to automation of data transmission in smart factories, stores, or any kind of commercial place. Of course, these systems will be made up of more than only what is written here. Then we have the CPS system is defined by its processing, storing and communication capabilities that will control more than one physical process. This system can also enable decentralized data analysis and decision-making that will enable real-time responses, as it is interconnected through the internet. Next up we have the big data and data analytics that will help processing and analyzing the huge amount of data generated by the users of the platform and thus bringing predictive data and solving futuristic problems and necessities. Then we have the simulation software that is in charge of collecting processed information to model behavior of the machine, also simulating future scenarios to determine necessities, predict problems, reduce configuration costs, and improve quality of services. This is also known as the digital twin concept. The cloud and edge computing is a very important part of this mechanism, but it sure has its limitation. In the future, as millions of devices will be connecting in the cloud. But we have different solutions there, such as fog computing or cloudless, and of course we have the cybersecurity aspect, because without security and privacy nothing will work. So, this is the key to provide secure and reliable communications authentication systems to preserve data and avoid any kind of cyber attacks. This is crucial to protect national security matters and industrial systems. Next up we have the social feature by which the geospatial data will be exploited and created. I believe that only a mobile application will be in measure to work such IT systems and infrastructures. So, basic features would include private user groups, public user groups, and individualized user groups so that one can be able to navigate through the system and have access to the data no matter the location. Geospatial data and interactive maps widgets should be available no matter the location of the user using the platform. I believe it will also be good to implement different type of social media interconnection for other in-app services such as social, public or private transportation using the maps to track in real-time movement and interaction with any interactive geospatial data. Also, we believe that other social media application can be interconnected to this system to achieve a greater data symbiosis. A few examples for social or private activities are meetings, location routes, messaging, and sharing moments. Also interconnecting with other social media application could leverage and harness valuable data. Next point was the 5G or the fifth generation technology for wireless telecommunication. The reason why this is here is because the rollout of 5G tech is incoming. There's already a few companies working on implementing such network as a standardized telecommunications networks, and 5G will bring enormous changes to the games. It'll change the data transfer speed by a lot. So, testing a network and framework as soon as possible to adjust to these changes and opportunities brought by the 5G is also crucial at this moment. This will provide customers with a greater network reliability. It'll also be of better use when 5G will be integrated to the advanced analytics with artificial intelligence, Internet of Things, for real-time insights and recommendations. That will be the future of the next generation of digital industry or commerce with the 5G. Of course, this is merely the potential of what 5G could really do in the Industry 4.0. Next up, we'll be looking at the four principles identified as the integral to Industry 4.0. The first one is the interconnection. It is the ability of the machines, devices, sensors, and people to connect and communicate with each other via the Internet of Things or Internet of People. Next one, we have the information transparency, which is the transparency afforded by Industry 4.0 technology providers operators with comprehensive information to inform decisions. Interconnectivity allows operators to collect immense amounts of data and information from all points in the manufacturing process, identify key areas that can benefit from improvement to increase functionality. Then the technical assistance that will assist humans in decision-making and problem-solving, and the ability to help humans with some difficult and unsafe tasks, and finally the decentralized decision, which is the ability of cyber-physical systems to make decisions on their own and to perform their tasks as autonomously as possible. Finally, here, in the conclusion, I'd like to discuss about the ethics behind such projects and craft. Well, first of all, we're in an epoch where every single polarity is shifting around us, and so is how the technology is used from now on. I think it's really important to understand the laws and work by its code of ethics, because this kind of IT system will shape a certain type of social behaviors globally from this point, and will also methodically frame different types of procedure as the technology is applied. And this is barely what the system can do. Also, ensuring the safety and security of such IE systems is a matter of national security, no matter what society will be using such technology. Also, I think it's the perfect time to develop shared public datasets and environments for artificial intelligence training and testing, because we're just starting moving into this new era of technology, and a lot of advancement are to be made. And finally, we need to expand, whether public or private partnerships arrangements, to accelerate advances in artificial intelligence implementation for global use. Thanks for listening to my presentation.
Can people hear me? Okay, Zoom is saying you can't, but I'm glad you can.
Yeah.
So that was Nicolas Rafael Palomino, or his computer helping him with English pronunciation, I guess, something like that. Nicolas is not here right now. It's a little too early for him, but he has been active in the chat before, so definitely leave your questions, and I'm sure he will follow up if any of those grand ideas struck your fancy. Our next talk up, Danielle Dupuy, will be speaking on embedding the rendering and behavior configuration in map data. So Danielle is a geographer with the US Geological Survey who works with the California Water Science Center's Groundwater Ambient Monitoring and Assessment Program. An important goal of that program is to increase the availability of quality information to the public, and with that goal, Danielle has been working on building web mapping with a templated approach. So Danielle, I'll let you take away.
Okay, hi. I recorded my presentation, so I'm gonna just play it because it was a little late. I don't trust my brain this hour.
That's great.
So let me know if hopefully you can see everything and that the audio will go through.
I can see it.
Okay.
Today I'm going to be sharing something that our team has been doing that's been helping to streamline our map development process. We've been including some of our maps rendering and behavior components into our map data rather than including it into the HTML or JavaScript directly. So this concept itself is pretty simple, but this exact approach is something that I haven't seen talked about or seen any examples online. So hopefully it's something new to you that you find useful and maybe you can implement into your own maps. And before we go any further, I just want to introduce you to and acknowledge my colleague Dan. He's an IT specialist with the USGS's Western Ecological Research Center. And he was the web developer that helped our department with its maps before I joined the team last year. And so this approach that I'm going to be talking about today was something that he actually came up with and implemented into our workflow. So I'm going to be kind of going over why we started doing this and what benefits we've been seeing and how we found it useful. And then I'll go over some examples of how we've been implementing this and show you some code of what we've been doing. So as I said before, Dan was the one who started implementing this, and he was doing this before I joined the team. And part of the reason was because he's part of our center's web development team, and he wasn't his full time wasn't to be working on our smaller team's maps, and he wasn't really intimately familiar with the data that he was being asked to display. And so this was kind of his way of allowing the scientists to author the data and who wanted these maps created to still have some control over some of the design aspects and be able to make tweaks to the map appearance themselves. And so, you know, it allowed people who don't have the knowledge or the access to directly edit the map to kind of play around with color renderings, remove items around in the legend on their own. And it worked well with our system because these changes that the scientists could make in the database where they had access to would then be immediately reflected onto our live staging site. So if they wanted to change a color, they can see it instantly, you know, on the map and make changes. And kind of in turn, this allowed our scientists to have control of these aspects without having to put in requests to our developer. So, you know, in our case, Dam's working on many different projects and could only kind of be working on stuff for our smaller team for, you know, a limited amount of time. So this kind of took off some of the burden off of him and allowed our scientists to just make these changes on their own. And when I joined the team a year ago, my role was kind of bridging the gap between the scientists and the web developers. You know, I'm pretty much a GIS person and I work on all aspects of with this data. So I'm definitely much more familiar with it than Dan was. So I kind of thought that maybe I would be using this approach less because I kind of had more knowledge and control over the maps and the way that we were presenting the data. But in reality, I've actually expanded how we've used this and am using it more, and I still find it very useful. I've found that I can kind of have more control over some aspects of the map rendering with writing less code, where like traditionally I would have to write a bunch of if statements to say, apply colors based on a study type for points that are being displayed. But using this approach, I can do all of that with one fell swoop, you know, using the color information that you store with the data that you're feeding into the site. And, you know, I just simply find it easier to make changes to these database values than having to go into the map code. It's kind of, you know, like a find and replace, but I just kind of find it easier to be looking at it in a table, and it's just a much easier workflow for me. And then, you know, I think this approach kind of opens up the door as a way to kind of almost automate or kind of greatly reduce the effort needed to create new maps. The way I see it is the less unique items that you put into your map code, the easier it is to reuse that code for a new map that has a similar structure. One of the cool things about this approach is that the possibilities are endless. So here are some examples of things that we've been using in our maps, but it's by no means a finite list. We've even used some of the map data to populate HTML IDs and then used those to render checkbox toggles based on the study types present in our data sets. And so, you know, if the map data changes and we no longer have a certain study type, it just won't be implemented into the map and we don't have to go in and change any HTML code. I'm going to show you how we used the map data to render the appearance of this site here. So we included in the map data all the information for these points, the colors, the sizes, the shapes, even kind of what plane they're drawn on, like the draw order, and also this sidebar here on the left. We've used some of the map data to render the toggle boxes and the points displayed here. We use a SQL Server database to store our data, and then we use stored procedures to serve that data to our .NET sites. So that's what's going on here in this table. This is kind of where we store the rendering information. We typically store it in a like legend item table. And in here we include all of the unique colors or symbols that would correspond with our data. So in this map, we had these 11 study types and each of them needed to be uniquely identified. So we changed symbol for each of the study classes, and then a unique color for each study type. And we also included the draw order. So it's kind of the pane, the leaflet, we're using a leaflet map. So it was the leaflet pane, which kind of identified which order the layers were being drawn onto the map. So down here is an example of the printout of our actual map data, the point data. So it's typical to how you would feed your data into a map, but then we add in the colors that each of the symbols, that each of the data points would get, along with the symbol size, and the draw order. So here is an example of the web method that we use to read that. From here, I just use an AJAX request to read the data, and then I applied the rendering information to the leaflet marker options. And by doing it this way, I was able to create or able to add that unique rendering for each of the data types without having to do any if statements. So I was able to do it all in one go. And then I applied these marker options into the points and create a layer. And then from there, the only kind of if statements that we had to do is because each study ID or each study type had to be a unique layer that we could toggle on and off. I just had to apply it to a layer group that I had already created. So this was kind of the only information that I had to hard code, which still worked for us, but maybe could be changed in the future. So here's another example, and this is how I created that left side panel. I did the same thing, used an AJAX request to read the data, and over here, I'm just using that information from the database to populate some of the HTML that's going to go and create a table on the side and kind of create the checkboxes, these toggle checkboxes. And then I just insert that into some divs that I had already written into the HTML code of the map. And so this here is the map that we just created, that code. We've got the nice sidebar that was with the checkboxes, but I noticed that the groundwater, because there's so many data points here, it was overwhelming all the other data layers, and since it was drawn on in pane 4, drawn on last, it is overwhelming everything else. So it's super easy just to go into the database and just change that pane here to be drawn first. I was easily able to just change the draw order around on all of the layers and create a much better looking map without having to touch the code at all. So that's it. It's pretty easy, but I think it saved our team a bunch of time. And if it's used in the right way, I also think it can open up the doors for some pretty cool stuff down the line. So like our team has a lot of data that we want to put into web maps. And, I've been working on kind of code that can easily be reused to create new maps faster. And usually, our maps show discrete water samples. So from map to map, things look pretty simple, just with minor tweaks to address the specific data and the story that needs to be told. But I think that using this, we can kind of get to a point where most of the unique elements can be included in the map data in the database. And then we couple that with kind of a generic template, and we can have a new map up and running in a matter of days as opposed to weeks or months. So, hopefully we can kind of get close to an automated system. Maybe it's a little far-fetched to be completely, automated and just be pumping out maps every day, but I think this can kind of get us closer. So thanks for your time, and I hope you found this helpful.
Well, thank you, Danielle, the live one and the recorded one. I don't think we've started a discourse page up for the topic, but I definitely think there is lots to say about it, and people who are doing similar things or who might even want to convince you to create a JSON LD schema to standardize this. I don't know, something like that. But moving right along, because we are tight for time, our next presenter is Chris Little.
Hi, can you hear me clearly?
Chris Little, yes, you are coming in loud and clear. Chris is
Thank
a
you.
professional meteorologist of many years at the Met Office UK and works on standards at both W3C and OGC. And Chris is going to present us a very brief history of meteorology and cartography so that we know where we have been, so we know where we can go.
Okay, so should I be presenting from my screen or from the thing that's been uploaded?
If you've got it, that would be great. Otherwise, I have to find it.
Fine. Okay, no, I've got it. I've just got to find my Zoom controls, share screen. Right, okay. Allow. I think it says allow. Do I need permission from you to share the screen?
You shouldn't. Got the
Okay,
green share screen button?
I've got a share screen, select screen, remember this decision, select window or screen. Ah, okay, yeah. Oh, okay, I've got to select the window. Right, fine.
Yep.
Okay. Why is that not working? I don't know. I'm not a Zoom person. Why is it not allowing? You can't. Oh, Firefox is stopping me. Drat.
I've got PDFs.
Firefox.
Do you want me to share and you can just tell me when
Yeah.
to move ahead?
Yep.
Okay.
Yep. They may be a bit tedious because there's a lot of pictures. Yeah, I didn't realize Firefox was so sort of strict. Okay. Cannot allow permanent access to your screen. Nope. Okay, Firefox is just not letting me do it. Okay, so can you just show the PDF? Yep, fine.
Yeah.
Right, next.
So.
That's on the screen. Yeah, so that's the structure of the talk. It's not, okay, it's, right, okay. Very straightforward, timeline, next. Okay, this is 3,500 years ago. This is a map from Mesopotamia. It's not the earliest map, though it's not disputed that it is a map. Next. And all talks about the history of meteorology involve the first documented weather forecast. This is Noah. It's a mosaic from St. Mark's in Venice. And the important thing about this is not that it was a weather forecast that was accurate, it was a long-range weather forecast, or the authoritative voice that gave the weather forecast. It's the fact that Noah acted on the forecast. If you're not going to change your behavior because of a weather forecast, there's no point in having a weather forecast. Next slide. And these are the people who didn't listen to the forecast and didn't pay attention to it, right? So, next. So, meteorology starts becoming documented about 2,500 years ago, 500 BC, with Aristotle. And he wrote a document called Meteorologica, from word and meteors, meteors being things you see in the sky. And the document came down to us via the Arabic, actually. It was translated into Arabic by Arabic scholars and then got translated back into Latin after the fall of Constantinople. And this is Aristotle's worldview. He lived in a temperate blue zone on a sphere. It was hot as you went south because you got close to the sun. It was cold at the north, and from arguments of symmetry, there must be a temperate and a cold zone at the bottom, which is actually rather good, actually, for 500 BC. Next. And then cartography, meteorology sort of stayed where it was. Aristotle was taken as the word for a few thousand years, but cartography improved. This is an Arabic chart. Don't try to read Arabic, it's upside down because I put north at the top, as they prefer to put south at the top. Next. And then we have, this is one from the Byzantine Empire, and this is built on Ptolemy's, the Egyptian. his map, and you can see we've got latitude, longitude lines. I've skipped about an hour's talk worth of cartography and its history. It missed out all of the Chinese maps, where in AD 200 they were putting grids and scales on their maps so you could measure distances. We've got distances on here. Next. And then all changed with this guy. This guy is Mercator, Gerardus Mercator. Next. And of course, he produced the Mercator map. And the important thing about this is only 60 years after Columbus went to America, and they've more or less got the shape of America right after 60 years. And the important thing about the map, of course, is if you sail on a constant bearing with your compass, you follow a straight line on the map. And it made global navigation much, much easier. Next. And now we get to where meteorology starts paying attention. And again, I've missed out about an hour's worth of talk on the history of meteorology and the Enlightenment and arising from the Renaissance and everybody's wish to measure everything. You know, all the stuff about Boyle and Hooke and inventing thermometers, and Torricelli inventing his barometer. This is Edmund Halley, the Astronomer Royal of the Comet fame, but before he made this fame over the Comet, he sailed that ship called the Paramour across the Atlantic and as a young man, and came back and published the next map. So this is probably the first weather map. It's the trade winds. And what's interesting here is we've now got accurate map and we've got arrows on it showing direction and speed, because big, stronger winds, longer arrows. So that's a key point. And again, I'm going to miss out about an hour's worth of talk on scientific visualization, and which is generally driven by the French. Next. But this guy, you may not have heard of, called Lambert, a Swiss mathematician, polymath, went to school with Gauss. And he suggested you should be plotting the weather on maps to figure out what was going on. Next. And he invented some weather symbols. And actually, they're pretty good, actually. We've sort of kept continuity with some of those symbols for a long time. Next. And the French came in with, this is just a pure orography. And we're now about 1700. Somebody's invented the contour map. Before then, it's just hashing, and this is the quantitative contour map that first occurred. And I've left in the there's a lot of notes in the original PowerPoint that has all this detail on, so perhaps post that later. I'm going to solve the problem of the size of the pudding. Now, this guy is the most famous scientist that the Brits have never heard of. That's a self-portrait by him, and that, of course, is Humboldt. Next map. He had some adventurous voyages as a young man, and more or less single-handedly invented geography and climatology. Next map. And caused to be published this map showing isotherms, lines of equal temperature. And next. And then towards the end of the 18th century, this guy called Brandes, who published a weather map. This is the weather for the day of 6th of March, 1783. The main problem is he took 30 years to produce it. It was actually published in 1816. And unfortunately, I haven't been able to find an image of what he looked like. So that's the first daily weather map, a synoptic weather map. Took 30 years. Next. Now things get interesting. You all know who this is. This is Admiral Beaufort, chief hydrographer, and of course responsible for a large part of the British Navy, and he invented a weather code. Next. So that all the ship's captains writing their logs and wanted to record that it was foggy and rainy and windy, just used a code, and it was standardized across the whole of the Navy. And next slide, it also standardized how to record the wind speed, which is interesting because this is using qualitative information to give a quantitative answer. And of course, that is still used in a slightly different variation to this day. And the other thing that Admiral Buffett do is he sent the next person on a voyage, and that's Fitzroy. Next. Fitzroy went on that joint for 3 years around the world, mapping the oceans because they were, hazard to shipping if you don't know where the reefs are. And next, and of course he took a young scientist with him, this guy, who in the next slide you'll recognize him, Darwin. Right, next. When Fitzroy came back, he eventually became a vice admiral. He set up the meteorological service in the UK. He was the official chief meteorological statist, and he had this bright idea that you could actually predict the weather. He didn't like the idea of using the word prediction. Prediction he thought was a bit too precise, so he called it forecasting. He invented the word forecasting. He thought forecasting gave this idea of slightly less accurate than a prediction. Next. Over in the US, this is Lieutenant Maury in the US Navy. He was no longer in active service, damaged his leg. He collected a lot of information from sailors, and he produced atlases to make sailing safer. Next slide. He produced the first oceanographic bathygraph of the Atlantic, the first map of an ocean basin. Right? And he also, no, go back again, just back to Maury. He was the first person to, he caused an international conference to be held in Brussels in 1853 to standardize the data. And 11 countries attended, and they all agreed on a standard form for measuring data from ships at sea. And so meteorologists, we've been used to using interoperable data and services for at least 150 years. Next slide. This is Galton, a scientist who caused Fitzroy to be defunded because he didn't like his forecasting because there was no science in it. It was just seat of the pants experience saying, a west wind is followed by a northwest wind. No science at all. He's a very eminent scientist, but a bit out of favor because he invented eugenics. But he invented correlation. He discovered fingerprints, and he did twin studies, and he invented the term anticyclone. Next slide. And he produced some maps. So here's a map of the weather on the January 1861, and he's kind of constrained by typesetting. So he had some type made, and the printer had to sort of set them and print the document. Next slide. And of course, if he didn't have observations, but he had kind of a coverage in the mapping terminology, a field, not very effective, but it's what the best he could do with printing. Next. And he also collected the weather observations by train. But telegraph was coming into effect as well. Electric telegraph rather than optical telegraph. And then lithography was invented. Lithography allowed you to draw your pictures on a stone. Rotary lithography became into widespread use in the 1850s, 1860s, so the newspapers could print pictures. And so then you started getting daily weather maps, and they're still usable. The isobars, they've got arrows, and there's been a daily weather map for the UK every day since. All right, next. Now, that's kind of history. And meteorology is not a science. So next slide. This all changed 120 years ago. This is Wilhelm Bjerknes. Next. He wrote down the equations of motion of the atmosphere. Next. Don't worry about them. They're tough. And they were first solved by hand by Lewis Fry Richardson. This guy, a Quaker, worked as an ambulance worker in the First World War. He spent 6 weeks solving those equations. Next slide. On this 4x4 grid at 4 levels in the atmosphere. He had levels, he had information on the depth of the atmosphere from artillery soundings by balloon from the First World War. So on this 4x4 grid, he did a calculation. It took him 6 weeks. Next slide. He used this hand calculator. It took him 6 weeks for a 6-hour forecast. which is a bit better than 30 years to produce a weather map. Unfortunately, his weather forecast was completely wrong. Not even just slightly wrong, it's completely wrong. It wasn't even meteorological. But the important thing was he published his results in 1922, 6 years later. And he didn't know why the equations were wrong, why he got the wrong answer. Next slide. Then things changed. Turing. Next. Jules Charny, child of Russian immigrants, lived in California, brilliant mathematician and very influential in meteorology. Next. Figured out what was wrong with Bjerknes's equations. They had sound waves in them, which kind of mucked up the answers. You don't want the whole atmosphere vibrating as a very loud sound. You filter those out and you get something that's a bit more meteorological. Next. So von Neumann, Hungarian, decided next weather forecasting, along with one or two other things, were worth computing on ENIAC, one of the first computers. Whole another hour's worth of lecture on the history of computing and who was first and who was not first. Next. And they did the weather forecast on a 270-point grid for North America. It took 24 hours on ENIAC. It took several weeks to set up the computer, but ENIAC took 24 hours to do a 24-hour forecast, and it was not wrong. It wasn't particularly good, but it wasn't wrong. So point proved. Next. And Moore's law solves the rest. Right? As the grids get finer, the forecasts get better, and as computers get faster, we can do finer grids. And as next slide, and by the way, I should say on the end of that slide, Moore's law is still adhering. We're still adhering to it. The Cray XC40 fits on the line at the top right-hand corner. So 2020 Cray XC40 fits in, and the weather forecasts have got better and better. So this is root mean square error of pressure over the Atlantic, and you can see over 30 years the forecast got much better. The horizontal purple line is persistence. That's how accurate a forecast is if you say today is the same as tomorrow will be the same as today, which is what you're trying to beat. Next. Now, oops. Then as computers developed, that's the Swedes had the bright idea of producing a zebra chart. That's a global map from the North Pole in the middle. Next. That's a Russian chart of now we've got plotting by hand and then drawing lines on a big piece of paper about A0 size. You can't read it as it's in Russian, but the symbols are all standardized and have been standardized for a long time, so any meteorologist can use it. Next. Here's a German chart. Again, you've got the plotted observations, you've got the contours drawn by hand, and we've got the fronts, which computers are not very good at fronts because they're discontinuities. Next. And of course, this is all completely different from the development of GIS and geospatial and mapping systems because they're meteorological. And this is a more up-to-date one because we've included satellite imagery showing the clouds, and we've got all the layers. This is now online, this is not on paper, it's on a screen. You switch the layers off and on, and of course then you start switching off some of the layers to make the map make more sense. Next. So you've removed some of the stuff, you've got the winds, you've got the arrows, you've got multiple layers of pressure, temperature, and areas of rain, for example, and that's a very standard meteorological chart. And next. And of course you remove even more data to give the chart or the map to the users. This is a standard chart that would be given to all airline pilots. All pilots in the world would receive a significant weather chart like this, removed all the spurious stuff and left in the stuff that's only important to the pilot, the significant weather, the strong winds, the base of the clouds, the height of the clouds, where the clouds are, where the thunderstorms are, and turbulence. And actually on that map, halfway down the left-hand side, you can see Etna is erupting, right? So there's a little volcano there, right? So, okay, next. And that's where we've been. Right, so then, this is the real part of the talk. In the 1980s, I was asked to do a 30-day demonstration of a piece of GIS software. In the 80s, GIS software started to be popular. There was no internet. There was no mobile phones. We were starting to get mini computers at work, and though we didn't use them for weather forecasting, spent a couple of weeks getting the data from the mainframe supercomputer down onto the mini computer. That's another story. The guy came in to do this 30-day trial of this piece of software. We ran it on, I think it was a DEC 11750. VAX 11750, took about an hour, produced the best weather map I've ever seen. Beautiful chart, beautiful contours, contours all labeled the right way up. And I then said, and he then said, well, oh, that's fantastic. I've never seen a weather map from a geospatial information system. And I said, are you going to buy the software? And I said, no. And he said, why? And he said, because it's just taken an hour to produce that chart. This is the biggest mini computer we've got, so we can produce 24 charts a day. We're already producing 100,000 charts a day. Right? So niche use of geospatial software systems stayed niche in meteorology for decades, just for specific products where you needed really fancy maps, while we chugged along with our thousands and thousands of maps. But then 10 years ago, we got involved in GIS because we discovered exchanging maps with web map services was feasible. So we've got involved. And that's more or less where we are now. We've been very involved in OGC and W3C. Next slide. I'm running out of time. Oh, so here's my thoughts where we should be going now. Okay, next. Meteorology has had this long history of tweaking technology, using technology, changing it. We used to write our own operating systems. We used to write our own programming languages. We had our own telecoms protocols because the mainstream ones weren't good enough or fast enough. And we stopped doing that now as they've got good enough. We've had our own data formats for 30, 40 years. They're quite advanced, scientific, container format. They're useful. And I can take the blame for some of them. And we're starting to move away from those to generic ones. But visualization, as I've just shown you, is still very specialized, and the semantics is totally specialized. But actually, visualization and semantics is exactly where GISs are. So next. But these are the problems. We don't have gigabytes of data. We have petabytes of data. The data is 3D and 4D. It's constantly changing. We've got multiple time attributes. Time intervals are irregular. Time scales are very varied from climate predictions over centuries, and we go backwards and forwards in time. We've got vertical coordinates, and they're not height above sea level or height above the terrain. They are pressure levels. Aircraft fly on pressure levels. They don't fly at an altitude. And we are not averse to saying, well, let's make the equator go through Paris. We'll put the North Pole in the middle of the Pacific, and we'll bend the South Pole so it's in the South Pacific. That's the kind of thing we do, right? That upsets geographers. And the other thing we do, of course, is we produce thousands of forecasts for the same time ensembles. Well, maybe hundreds. Next slide. So they're all problematic for large-scale map production. And that trend is going to continue. As we can afford the next computer, resolution is going to improve. Global models are currently running at about 10-kilometer grid, and it will slowly come down to a high resolution. Nested grids running at 1 kilometer, they may go to lower than that, not much lower, because you then get into problems with turbulence. So data is going to get bigger and bigger. We're routinely blending it with lots of other people's data. And we're kind of moving away from our domain-specific solutions to more generic solutions, which is where W3C comes in, of course. And of course, we've got our own visualization. So move next slide. We're getting towards the end. The problem we have with GIS systems and maps and cartography is layers don't cut it for us. We've had one of the saddest things I see is a mapping specialist in the last 4 or 5 years coming along and saying, oh, look, we've put a time slider and a vertical slider on our mapping software. I said, oh, sorry, we've been doing it for 30 years, right? And if you've got 100 layers in the atmosphere, 110 levels in the atmosphere, and you've got 10 data times. You know, the forecast for every 6 hours for the next 4 or 5 days. You've got 100 levels, not 100 levels, 100 parameters you're interested in. You're talking about millions of layers. There's no way you're going to select those off a legend, right? So the layer metaphor is broken for us. Next. Now, if I look at what's going on inside OGC, which is about interoperability standards for mapping, there's a lot of 3D activity going on. We've got flight simulation, we've got gaming, we've got unmanned vehicles, in particular drones, both above ground, on ground, and below ground, underwater. We've got underground modeling going on for tunneling. We've got smart cities, 3D portrayal of smart cities, and none of those are based on the traditional 2D cartography. They're all completely coming from a different place. And there's still this attempt to say, we can get to 3D by starting from 2D and adding the extra dimensions. Well, you can sort of, but actually it's much easier to start from 3D. Because, for example, on the previous talk from Danielle, I thought it was very interesting that she's kind of reinventing in JavaScript and JSON all the stuff that the hardware is already doing in the GPU. GPUs in most devices, phones and laptops, are designed to do 3D graphics. They've got hardware to do 3D graphics, and actually it's more work to do it in 2D. You have to sort of, zero out some of the matrices, but they are they're all set up to do it. So in a sense, I'm taking the view that we should really be doing mapping in 3D, and then if you just look downwards, you see the 2D map. And of course, that solves some fundamental problems. If it's in 3D, you don't have any problems about whether the red road goes over the blue river or under the black railway track. That problem of drawing things on maps and the drawing order just goes away. It's in 3D, right? And when you do the projection, you then get the right drawing order. And of course, then if you do it in 3D, you can do vertical maps, cross sections, which are important to meteorology. Next. So this is my last slide. Where do we think we're going to go? Where does technology allow us to go? I think in 5 years' time we won't have any meteorological software anymore. There's been a big industry over it, and it's slowly diminished. Fewer and fewer players, more and more sophisticated. It'll just become GIS systems, generic software, and meteorological style sheets. The real issue in any visualization is handling the data, not actually the visualization. In 10 years, where will the GIS systems be? And I'm just going to posit that there won't be any GIS systems. All the browsers will be doing it. Browsers will be aware of where you are, and that all data will be geospatial. And that's my view, really. The rest of the bit, arm waving. So I think really the important thing is that the vertical and time have to become first-class citizens in the mapping world. Right, so that's where I'm going to stop. Next slide, any questions? I hope I didn't overrun too much.
Well, we're all overrunning today, so I'm going to say questions can go onto Gitter or Discourse.
Yep.
We're going to continue along with our last talk of the day. So let me get my notes. Sajeevan Ji is Associate Director at CDAC, the Center for Development of Advanced Computing, which is associated with the Government of India. He has more than 25 years in geospatial domain. He will be speaking to us about WebGIS application for the Indian Prime Minister's Rural Road Program. Sajeevan, welcome.
Hi. Is it audible?
Yes, we can hear you.
Can I share my screen?
We can see it.
good to go? Is it okay?
All good.
Okay. So the topic is WebGIS application for Indian Prime Minister's Rural Road Program. I am Sajeevan, and we are into high performance computing. CDAC is since inception in 1988. We are into high performance computing and close to 3,000 people all over India. And my group is working on geospatial technologies. And let me, and the next slide. Okay. So I'll be talking about Prime Minister Rural Road Program. So otherwise I'll be referring to PMGSY. PMGSY stands for Pradhan Mantri Gram Sadak Yojana and Indian language. And the programs, the pictures, what you see in the photographs which you see in the left side speaks about the importance of Rural Road Program launched by Government of India to provide all-weather road connectivity to unconnected rural habitations. You could see you will see starting with 2000, year 2000, the PMGSY. I will always be referring to PMGSY for the Prime Minister Rural Road Program. So this has changed the face of the rural India with quality roads. Previously, you used to have really very bad road in India. The quality of road is really commendable, and the program is funded by World Bank. And this particularly the Rural Road Program has helped alleviation of poverty, access to market, employment, healthcare and education, and a lot of things has changed the way the PMGS has worked. Okay, a little bit of history about the program, how we started. Now let me come into WebGIS, the topic of my presentation today. And we have started with the PMGS, started with customizing the ARC way back in 2005. And parallelly, at that time, it's in 2005-06, we have even customized WebGIS application. That is a map extreme. Can I hide it? Okay, good. Okay, the WebGIS application, which is developed using ASP.NET, and the engine behind is a map extreme. And if you look into this, and we have worked as if like a standalone GIS software, you could see the map. And then this picture in the right side, which is called Crumbs Web, you can see the users can make a lot of query like what is the habitation which is connected, or what is the village road, and the person is able to see the attribute information just like a standalone system and see the details below. And coming currently, that was a history way back in 2005-06, and currently we have what is called the GRIS that is open to public. Anybody can go to this particular site, www.pmgsgris.nic.in, and a lot of information about the program as such, and seeing it especially how the data, how the things are connected, how the road is. It is for the decision makers as well as for the public. That is basically, it is open to general public. Here also you could see the classifications, different category of populations. We can make the colorful maps with a lot of legends. And once you go into the particular system, each state in India, you can go there, select the scheme, whether it is in PMGSY 1 or 2, or currently 3 is going on, different schemes, and in which the government is approving particular type of roads. And basically it has started with the aim of connecting, initially it started with habitations which are above 500 populations, and then hilly and populations with backward classes, SC and ST, we have started connecting with the 250 population. Population means in a particular cluster of human population, or in a habitation, the population should be 250 or above. And in this publicly available system, you have, you can see the legend, something around 23 layers of GIS layers, habitation, roads, and drainage, a lot of information which is required for the managing and monitoring of the PMGSY program. And we call it as PMGSY National GIS to address it. Okay. So most important positive things about this particular WebGIS application, which is currently available, it is a live non-spatial data integration. That means in the GIS, we just have the features. That means we don't have any other information other than ID and the spatial information. The rest of the information is coming from the MIS system, which is hosted somewhere else. And that particular application also available public information omms.nic.in, which we can be accessed. So what happening is the information about each feature is getting updated within the OMMS MIS system. And within the GIS system, we have just the spatial information, and both of them talk to each other. And previously what you have seen in the particular thing, here even the information about the habitation, what the habitation, name of the habitation, all the queries, everything coming from the MIS system live. So this has kept the particular system live and current, so that normally otherwise, unless and until you update the GIS system, it is very difficult to get updated. So it is almost, as I showed you previously, it is working like a live standalone system. The user is able to query the system, user is able to get the result, and they are able to see the tables of each feature. Clicking on certain feature, we can see the more information about that. And what we lacked in this particular engine, the behind this GRIS, what I call the GRIS, the previous software, it's a transaction-based thing. So GIS engine, it is map extreme engine. So we were trying to find out how we can transact with the GIS system. We can update it online. So we have come up with the online geospatial transaction system that has been developed completely using free and open source software. And probably if the time permits, actually, unfortunately, I'm barely in another training program. So maybe if it is possible today or another day, we'll be able to demonstrate if you're interested, but I will cover a lot of things. And apparently my member Parth is also attending it. Parth is already attending. He's a developer of this particular system. And if time permits, or he can also show some demo here, because I'll be moving out to another program. So let's have a basic look into the GeoStat, what we call the online geospatial transaction system. Means the user should be able to log in. It's based on authentication. There's a login screen. And once the user is authenticated, the user can go and change the data online. And basically start with uploading the data. The beauty of the system is the shape files can be uploaded online. It get automatically published within the system, whatever the user is. So previously what used to happen is each state in India used to send the data to CDAC. We used to manually do the quality controls. We started making the compatibility table, how it is managing and compatible with the MIS system, how many features are missing or how many are perfectly aligned with the MIS system. So we check it manually and used to send the report. So now the system is currently live, but is waiting for launch. So I will not, probably I should not go into much details, but the interesting thing is users can upload the information, the shapefile, and make the QC reports online, see how the things are, and modify the system online. And also they can make a state report. After you edit it, you add more data, how the status compared to the MIS system, how many are missing. All these reports can be national report, as well as there is a utility for trace map. I will show you some slide and the subsequent presentations. It is already the next slide. Also, there is an option to download. The users, once you edit everything, and the users can download the shapefile online, and they can modify in case they require. Again, they can upload it into the system, or they can modify it online. Also, there is an option to give the OGC standard web services to other agencies, because nowadays people are, as you know, it is asking for other publishers are asking for shapefiles. So the system is enriched with giving the OGC standard geospatial service to other agencies. So this is about the editing I was talking about. Once the user logged in, there is an option to, based on the user, they will be taken to particular area. It is actually the user is not able to edit outside this area of influence. So for example, there is in every state, there is a project implementation unit. So they will be given a login. There will be so many logins, and there will be a state administrator who will be approving the whatever changes done by the user. So from the left side of the list, as you see here, left side of the drop-down list, the user can select any of the WFS services which need to be edited. And on the right side, you can also see a WMS services. Basically, the services coming from externally. The first service you see, the Bhuvan, that is coming from Indian Space Research Organization. So the satellite data you see and this particular display is coming, the ISRO Bhuvan, the satellite data. Also, there is an option to access OpenStreetMap or any other satellite data can be added in the external service. And below that, the GIS layer is internal services which we created using like a WFS services, WMS services, which can be put in the background so that they will be very faster and people will be able to see comparatively what is behind, maybe the drainage, maybe the proposals, maybe the roads. And the user can also talk the information, because the information about some of the features, these are coming from the MIS, live access from the MIS system. You can see it is just like the behind this particular thing is the open layers, the front end is the open layers, and the back end we have a lot many technologies like GeoServer. So some of the things in GDAL, then post-GIS, so many technologies in the back end. So one utility which I say the web services or web API, because the system is having a lot of APIs. And one thing I just am going to show is the benefited applications, because the people are interested, the MIS system is interested in knowing the benefited applications. Suppose we construct a road, the things what you see in this particular, whatever magenta or whatever color you see, there is a road, which the MIS system is passing to this particular GIS system, in which he wants a habitation actually benefited out of constructing the road. So once we construct one road, the people are interested in knowing what are the habitations which is benefited out of it. But MIS has limitations. MIS people just enter it. They just say, okay, this many habitations are benefited. But spatially, is that true? So that verification is done through the GIS system. Within the 3-kilometer radius, we take all the habitations. And also we find out the routes, how much it takes to reach each habitation. So it's a simulation, because simulation we do to, sorry, not the simulation, coming to the next one, is the finding out the shortest route to reach each habitation. Whatever is within 3-kilometer distance we are returning, those are the benefited habitation. That is a criteria defined by PMGSY. So right side, you could see the JSON string, which is given to the MIS system. And the left side, you can see what is actually happening, geospatial analysis, what we do internally to arrive at. One more thing I just wanted to show you, the simulation for road prioritization, what we call it a trace map, as I showed you in the beginning. So which road to be taken on priority for the construction or maintenance? That's what we are doing it over here. So since it's very difficult to keep on updating the traffic intensity, what we are doing is simulation. So what we are doing here is, it's particularly specifically for the PMGSY program, which is right now to facilitate identification, prioritization. So what we give is, maybe we'll take the top 10 roads. Okay, these are the roads which we have suggested, the system has suggested based on the shortest route and parameters of population, how many population that road is serving, agriculture, market, education, and medical facility. 3 important things which are going to consider: the marketplace, is there a marketplace, or education institution, or medical facility. So if there is a facility like these, So each habitation, as you see here, each dot, the people from that place will be moving to all these facilities. So we find from each habitation, these travels to all the facilities and keep on tracing the maps. It is a simulation, continuously finding the shortest route. And finally, we find out the topmost road based on the frequency. It's like a heat map. So the topmost maybe 10 we provide to that. Here you can see the maybe the red color is used most of the time. So that should be taken on priority to. These are all just showing some of the things which you do it in GIS. So some of the suggestions, so that was about my topic. Some of the suggestions I would like to give the map for HTML. Hello, audible? Hello?
Hello.
Am I audible?
Oh, yes.
Yeah, okay. So before it's for just for the understanding, but maybe useful for the programmers or others who will be coding it. So all of us know the WGS84 ellipsoid and datum. So most important, people may be confused, so they can go to this particular paper or my research topics and they can get to understand what you, because there is a confusion normally, people confuse between the authalic latitude and geodetic latitude. So it is not the thing we are normally considering Earth as a sphere, and we are not considering Earth as a sphere, we are considering it as an ellipsoid. So the geodetic latitude at a location is the angle between the equatorial plane and the line normal to the reference spheroid. That means in case the user is standing at the point X, there is a WGS84 ellipsoid, which I see, the phi is the geodetic latitude. If it is an authalic latitude, that is an alpha. If it is standing, that is alpha. So there is really a clearly difference between the geodetic latitude and the geodetic authalic latitude. So we should be very clear about wherever we are standing. When we are taking the angle, we are taking the angle normal to the ellipsoid or the spheroid surface. So that means it will not go through the center except at equator or the north and south, whatever we consider. So this is very important in terms of spatial accuracy, because of the papers which I have, even we can go through that, and so that we will not make a compromise on the spatial accuracies. Another very interesting and important thing I just wanted to make a point of, my suggestion is here. You can see both are from Google, on Google Map in the left and right side. I have given a green border, which is a global view. You can see the green line, how the shape and the size compared to Canada, you could see that. But at the same time, in the left side, the green line compared to the size, you can say it is very small because it is a Mercator projection. And if you make some of the measurements on this, visually they appear really incorrect. So what I suggest, we could maybe probably go with this type of displays, like in a globe view, and so that once people zoom in, they could take you to that particular place, and when we can go with a projection normal to that. So we could avoid, for example, in the next slide, I will show you the size of Antarctica. Even see that from here also we used to participate in Antarctic expeditions. So if you plot it here, you can see it's the visual it is going to be, you may not be able to use this in a particular projection if you use this as Mercator projection, Mercator projection, or whatever projections in the Cartesian way. If you use it, it's going to be really like the size, shape, and other thing may not be good compared to that. So in fact, you can, in the right side, you could see the size of Antarctica when you put it in a global view. And what I suggest based on this is how we are achieving it is what the thing is, okay, what I suggest in the green color, avoid standard map projection and implement on the fly projection at the viewer. So this we have implemented even in PMGSY, the Pradhan Mantri Gram Sadak Yojana, which you are talking about. So we just clearly said previously what we used to have is we used to have a base map over which people used to plotted things. So here we have said no projection. So we don't have a projection. So what we have, the normal geodetic latitude and longitude, people are mapping the information, the latitude, longitude, probably they use the GPS unit. Or if the previous map, what we have, we need to convert those maps into proper basic latitude and longitude. So they remain in the same project. So if you start reprojecting the projections, reprojection after reprojection, there is a chance of getting the accuracy getting lost. So what we are not living in an age of like a paper maps. So we could keep the paper map when we used to have the coordinate system. Then once we have projected onto once we have the information over the ellipsoid or spheroid, then the last stage we used to take the projections where it be cylindrical, conical, or azimuthal projection. So we don't have to do that. That's what my point of view is. You keep the information there, as and when required, you just project it. So in the digital world, you can project in the last stage as and when it is required. That's what is happening. That's the maybe going ahead, that is going to be the best practices, because you keep on reprojecting and reprojecting without doing, there is a possibility of like accuracy getting lost. So the thing I just wanted to make again is a global view, like Google Earth, as you see here. Probably we can look into that way, and as well as location scale aware. So once you zoom into that, you can give the information as such, or the projection the way you want. Or if it is too much good zoom scale, when you can think of any of the like a beat, like a Cartesian coordinate or projection in that way also. Anything will do. And location aware, where you are standing. Or if you keep the information of, suppose if it is in South Pole, if you keep the information in the base that long, so once you plot it here, they will appear very nicely. But if you keep it in already projected systems like easting, northing, all those things, so the information transferring and converting will be compromising on the quality. And also I suggest the raster vector, as well as we need to give the provision to give the web data services, provision to maybe locally the information, the people should be able to access the data web services. And as I already told you, this spatial accuracy is very important, so that we can have the interoperability properly. So otherwise, previously what used to be normally we face in India is, so a lot of, initially our data is in Everest and polygonic projection. So in case anybody make a mistake in converting those things without understanding the base projection, and maybe they convert it into, without understanding, take the map and project it in WGS84, that is going to be wrong, and it is very difficult to correct afterwards unless and until we geocode it. So that way, considering the spatial accuracy, we should have it. And some more suggestions, okay, we should have definitely the web API now. What is the time for the web APIs to come? And most another thing is the previous, I think, speakers already talked about cybersecurity. It is very important we keep the cybersecurity intact, so that the user will be expecting a trustworthy data. The data security is very important. And when I am expecting, when I need a data, the data should be available. I should not get the data security, because what I meant is because somebody should not manipulate the data somewhere. So what we have here is in PNGs, we have authenticated and certain privileges are given. And we have implemented some of the things like anyway, SSL, all those things we could implement wherever possible. So when we are sharing the data right now in the WMS or WFS services, normally we are giving the URL. So we need to also work on how to authenticate those things properly, so that somebody else is coming to know the URL. They should not be able to hijack the data. So we need to work on authentications and authorizations properly. So able to, on the fly, maybe accessing GeoServer, how we should be able to, how we can manage those. And in case, I think previously someone was talking about, some speakers were also talking about the prioritizing or selecting some of the data projection. That may be difficult. Maybe what I feel is how to prioritize it, or we may build like a professional software, like a commercial software, maybe adding all the projections and datums. So initially, I think I have a lot of collaborations with Canada, PCA, Geomatica. Initially, way back in 2000, I customized a lot in Geomatica. It was used to be a very powerful, especially in projection, and I think that was really a good product. And with this initiative, I think we should expect enormous contribution from the developer community. So the HTML map viewer, and if we are able to put it into an HTML, so the contributions coming from the developers around the world. So the geospatial data as a service could be the next business opportunity. Like people could serve based on their requirement. I may not be interested in keeping my entire data here. I may be interested in only a small output. Maybe I just wanted to see what is the benefit of habitation. So I don't want to keep all the data. I just want maybe a one-time requirement. So somebody else could give me a service and I could use those data. So we should expect maybe a data as a service, geospatial data service could be a next thing. And thank you all. With this, I ended. In case maybe you can have the question answer, or in case you want a demo later onwards, my member Parth can give, or we can have it in another day.
Thank you, Sajeevan. Unfortunately, we are well over time today, so we won't do that, but maybe get in touch with the program committee. We might have time for that demo later in the week. And thank you. You covered so many different issues. I'm sure there will be discussion.
Yes, great
we
talk.
will follow up with the discourse pages and many threads of ideas there. There has been already lots of interesting discussion, and so I know we're losing participants. We're going to close down the video session, but the conversation continues online. Thank you, everyone who has been here today or who is catching up via video.
Thank you, Peter.
Thank you very much, Sajeevan.
Thank you.
Pleasure to meet you.
Yeah, very nice. We had a lot of interactions. Okay.
Excellent advice.
Okay, good.
Thanks, everyone.
We will see you all again in a little less than 30 hours.
Okay.
Good night. Good
day.
day.
Yeah, good.
Thank you. Thank you, Emily.
Thank you.